London gets less rain every year than New York City. Let that sink in for a second. The city that became the global symbol of miserable, constant, gray, drizzly weather actually receives less total annual rainfall than one of America's biggest cities. So why does Britain feel so wet? Why does the weather dominate every British conversation? Why do people carry umbrellas in July? The answer has nothing to do with how much it rains. It has everything to do with where Britain sits on the planet, and an invisible river of warm air and water vapor crossing 3,000 miles of Atlantic Ocean to find it. And by the end of this video, you'll never complain about British weather the same way again. Most people have a simple explanation for UK rain. Britain is an island. It's surrounded by ocean. Ocean means water. Water means rain. Simple. And honestly, that's not completely wrong. The ocean absolutely plays a role, but it's the laziest possible version of the actual answer. Here's the crack in that thinking. Plenty of places are surrounded by ocean and don't get this kind of constant, gray, drizzly weather. Hawaii sits in the middle of the Pacific. It's warm and sunny most of the time. The Azores, Portugal's Atlantic islands, sit even further into the Atlantic than Britain. They're mild and pleasant year-round. So it's an island near the ocean doesn't explain it. Not even close. What actually explains British weather is a specific combination of three things, all working, together, all the time, all year round, that no other major populated country in the world experiences in quite the same way. Here are the three questions we're going to answer today. What is the invisible Atlantic system that pumps moisture directly at Britain every single day? Why does Britain's specific geography turn that moisture into constant rain instead of letting it pass? And why does Britain feel wetter than places that actually receive more rain? So let's go deeper than anyone has ever taken you before. Let's start with the thing making all of this possible, the Gulf Stream. The Gulf Stream is one of the most powerful ocean currents on Earth. It begins in the warm waters of the Gulf of Mexico, where water temperatures can reach 30 degrees Celsius, and flows northeastward across the Atlantic Ocean toward Europe. Think of it as a massive conveyor belt of warm water, 100 times more powerful than all the world's rivers combined, carrying heat from the tropics and dumping it right on Britain's doorstep. By the time that warm water reaches the North Atlantic near Britain, it has released enormous amounts of heat into the atmosphere above it. That heat warms the air, and warm air holds moisture. Lots of it. So the atmosphere above the North Atlantic, the same atmosphere that Britain sits directly in, the path of, is constantly loaded with warm, moist air, being refreshed and recharged by the Gulf Stream every single day. Without the Gulf Stream, Britain would be as cold as Canada, same latitude. Newfoundland sits at roughly the same latitude as southern England, but Newfoundland gets brutal winters with heavy snow. Britain gets mild, wet gray. The Gulf Stream is why Britain exists as a habitable place at all. Now here's the delivery mechanism. Sitting at roughly 50 to 60 degrees north latitude, Britain sits directly in the path of what meteorologists call the Prevailing Westerlies, a band of wind that blows consistently from west to east across the entire planet at that latitude. These aren't occasional winds. They're permanent, constant. They blow from the Atlantic toward Britain every single day of the year, carrying all that Gulf Stream moisture with them. As this warm, moist air travels across the Atlantic and approaches Britain, it's essentially a flying river of water vapor, invisible, but carrying enormous amounts of moisture ready to become rain the moment conditions are right. And Britain's geography makes sure those conditions are almost always right. Did you know the UK receives moisture that evaporated from the Gulf of Mexico, over 5,000 miles away? The rain falling on Manchester might have started its journey as warm water in the Caribbean. But here's the part that nobody talks about. It's not the Atlantic moisture that makes Britain feel so relentlessly wet. It's what happens to that moisture the moment it hits the British coastline. And it involves something called orographic lift, one of the most powerful and least understood weather mechanisms on Earth. When that moisture-loaded Atlantic air hits Britain's western coastline, it immediately runs into hills and mountains, Wales, the Pennines, the Scottish Highlands. And here's the physics. When air is forced upward over high ground, It expands and cools. Cool air cannot hold as much moisture as warm air, so the moisture condenses and falls as rain, right on the western side of the hills. This process is called orographic lift, and it means that Western Britain essentially acts as a giant rain trap. Every time Atlantic air crosses the coastline and hits rising ground, it is physically squeezed of its moisture. That's why Western Scotland, Wales, and the Lake District are dramatically wetter than Eastern England. The mountains extract the rain. By the time air reaches the eastern side, it has already dumped most of its moisture. Coming up, what this weather pattern is doing to Britain's infrastructure, why engineers have been fighting it for decades, and the one climate statistic about the UK that will completely reframe how you think about British weather. In school, British weather gets explained in about 2 sentences. Island near the ocean gets a lot of rain. That's it. What meteorologists and civil engineers who actually work with UK weather know is something far more specific and far more consequential. Britain doesn't just get rain. It gets a specific type of weather system called an Atlantic low-pressure system that is the real engine behind the gray, drizzly, unpredictable pattern everyone recognizes. Low-pressure systems form over the warm Atlantic when warm, moist air rises, leaving an area of lower pressure at the surface. Surrounding air rushes in to fill the gap, spinning counterclockwise in the northern hemisphere, creating the rotating storm systems that march across the Atlantic toward Britain in an almost constant parade. These systems arrive roughly every 3 to 5 days throughout the year. Each one brings cloud cover, mild temperatures, and that characteristic light, persistent drizzle that doesn't feel dramatic but accumulates quickly. British civil engineers designing drainage systems, road surfaces, and building materials have had to specifically account for this pattern, not heavy downpours, but sustained, frequent light rain across a long annual period. UK road surfaces are engineered with drainage gradients significantly steeper than equivalent roads in drier European countries. UK building regulations require roof drainage systems capable of handling sustained, low-intensity rainfall rather than the high-intensity, but brief downpours that characterize continental climates. Wait, it gets even more interesting. In January 1953, a severe Atlantic low-pressure system combined with high tides to create a catastrophic storm surge along Britain's east coast. The sea level rose over 5 meters in some areas. Over 300 people died in England alone. Over 1,800 died in the Netherlands. It was the worst peacetime disaster in both countries in the 20th century, and it was caused by exactly the same Atlantic low-pressure system pattern that creates Britain's everyday drizzle, but at extreme intensity. The response was the Thames Barrier, one of the most ambitious engineering projects in British a movable flood barrier across the River Thames protecting London, completed in 1982 after 8 years of construction. It has been raised over 200 times since opening. Here is the most shocking fact in this entire video. London receives approximately 600 millimeters of rain per year. New York City receives 1,200 millimeters. Rome receives 800 millimeters. Madrid receives 450 millimeters. Yet Britain has the global reputation for constant rain because it rains on more days per year than almost anywhere else in Europe, even though the total volume is relatively modest. It's the frequency, not the quantity, that defines British weather. You've probably noticed that British weather conversations follow a very specific pattern. It's not about dramatic storms or floods. It's about the persistent, low-level grayness, the drizzle that never quite commits to being proper rain, the sky that never quite commits to being properly cloudy or properly clear. That pattern, the one that defines British life and culture, is a direct product of orographic, lift, prevailing westerlies, and Atlantic low-pressure systems working together in a cycle that never fully stops throughout the year. Next time you hear someone say, "It rains every day in Britain," what they actually mean is that the sky is overcast and threatens rain almost every day. The actual rain is often lighter than people in truly wet climates would even notice. The same Atlantic low-pressure systems that have defined British weather for millennia are now being studied intensively by climate scientists because their patterns are changing. As Atlantic Ocean temperatures rise, the Gulf Stream system that drives Britain's mild, wet climate is showing signs of weakening. A significantly weakened Gulf Stream could mean winters in Britain getting dramatically colder, not wetter, as the warm Atlantic heat pump loses power. The low-pressure system physics that drives UK weather works exactly like your bathroom, an extractor fan, creating a pressure difference that pulls surrounding air inward in a rotating pattern. Same physics, wildly different scale. Now here's something most people never connect to this topic. The weather everyone complains about is the only reason Britain looks the way it does. The green fields, the hedgerows, the rolling hills of the countryside that define the British landscape, all of it requires consistent year-round moisture to stay green. Countries at similar latitudes without the Atlantic moisture system, northern Russia, northern Canada, are either frozen tundra or dry boreal forest, not green, not rolling, not quintessentially British. The rain isn't an inconvenience that happened to Britain. It's the reason Britain's landscape, the fields, the gardens, the rivers, has developed as it has over thousands of years. Remove the Atlantic weather system, and Britain looks nothing like Britain. Think of the Atlantic weather system as Britain's automatic garden sprinkler, running on a timer that never fully switches off, keeping everything green regardless of what season it is, regardless of what anyone does about it. The British don't have wet weather. They have a permanently irrigated island. The perspective just depends on whether you'd rear the grass or the person trying to have a barbecue. London gets less annual rain than New York, but the Gulf Stream delivers constant Atlantic moisture. The prevailing westerlies push it straight at Britain every day, and Orographic Lift over mountains squeezes it into persistent drizzle across the western half of the North country. That combination of frequency over volume, rain on more days rather than more rain per day, is what makes Britain feel so perpetually wet while technically being less rainy than many other cities. And the same Atlantic system everyone complains about is the only reason the British countryside is green, mild, and habitable rather than frozen or dry. Britain isn't the wettest place in Europe. It's just the most efficiently and persistently watered by a planetary weather system so reliable it shaped an entire national culture around complaining about it. Did you know London was drier than New York? Drop it in the comments. I want to know who actually knew that one. In our next video, we're going somewhere even stranger. We're going to find out why the deepest hole ever drilled into Earth had to be abandoned, and what came up from inside it that nobody expected. The world is not what it looks like on the surface. It never was. This is Logivra, and the logic was always there. You just needed someone to show you where to look.